Carol, ready? Okay. This is my friend Avery, and she's a 4th grader at the Lexington School, and she has a wonderful teacher named Mrs. Zimmerman, who I know lets her do a lot of hands-on experiments, right? You guys do a lot of hands-on stuff in the class?
Yeah.
Okay. So today, Avery is going to help me with an experiment involving diffusion. Have you ever heard of diffusion?
No.
Okay. So diffusion is when you have an area of high concentration, meaning you have a lot of stuff in one place, and then it goes to an area of low concentration, which means it kind of starts to spread out in something. So we're going to put food coloring in drops of water, and you're going to observe if the food coloring diffuses faster in hot water or cold water. Okay. So so that's sort of like the basis of our experiment. So what we're using today is we're using room temperature water, hot water, 2 bowls of the exact same size, bowl number 1, bowl number 2, red food coloring, blue food coloring if you used food coloring before.
Yes.
So you know it's not like dangerous or toxic. Okay. And we are going to use my phone as a timer. Okay. And because we're scientists right now, we're gonna follow the 7 steps of the scientific method. You want to take that off?
Yeah, I'm gonna take this off because it's white.
Okay. Oh, you want to get your food coloring? Okay. So the 7 steps of the scientific method are very helpful because what you do is that's how every scientist does an experiment. So then you know it's like an official experiment. Okay. So the first thing we're gonna do. First step of the 7 steps is we're going to state the problem.
Okay.
It's not really so much as a problem as like a question. Okay. And the question is, does temperature affect the rate of diffusion? And diffusion, remember, something goes from area a lot in one place, high concentration, to an area of lower concentration. Okay. Sort of like if you were to take concentrated lemonade, and you put a big blob of it in water, and you see it in a big blob, and then if you were to watch it, you'd see how long it would take to be in one big blob, and then sort of spread out and go from high concentration to low concentration. Okay, so we're just going to ignore the phone ringing. So we're going to, okay, so does temperature affect the rate of diffusion? So we're going to start with, okay, so that's step number 1 of the scientific steps. Step number 2 is gathering information. So if we were to mix food coloring in 2 different containers of water, one with cold and one with warm water, would the rate of diffusion of the food coloring be affected by the temperature? So that means, would it diffuse faster in one temperature, or would it just be the same? Okay? And so, do you have any predictions? So if there's hot water in one and cold water in another?
Maybe that the hot water makes it dissolve faster.
Okay, do you have any idea why?
No.
No, okay, well good. Okay, that's fine. And so predicting is also part of the 6 basic processes of science. So we're using two different methods at the same time. Okay, so we design our experiment. And we have 2 glass containers, the warm water, the food coloring, a thermometer, measuring cup, and a timer on my phone. The next step is the steps to investigate basically what we're doing, which is basically the experiment. Okay, and we'll do that. Then we're going to record the data. So after 20 seconds, 40 seconds, and 60 seconds, I'm going to need you to write your observations in these boxes. Okay. So we're going to measure, and then we're going to observe, and then afterwards we're going to talk about what you observed, okay? And then we will form a conclusion, which basically means, what do you think happened?
Yeah.
Okay, but it's all...
Like
exactly. It may not go right, okay?
It may go at the same time.
You just never know. You just never know, so we'll figure it out, okay? And then another one of the 6 basic processes will be inferring, which is a word for means like, what I want to know what you think happened, okay? And then we'll sort of figure out if you can apply this to a real life situation. All right? Okay, so the first thing I'm going to have you do, all right, is we are going to measure 2 cups of room temperature water into bowl number 1. And what I've done is I've had this sitting out for about an hour. I just took it out of the tap. So it's room temperature. Okay. So how many cups do you see there?
That is 2 cups.
Okay, so can you please pour the 2 cups into bowl number 1?
Okay.
There you go. Excellent. Okay, now this is water that I've warmed up in the microwave.
Okay.
And can you pour 2 cups of water into there? Do you need any help or you got it?
No.
Okay, but we're going to pour it in the measuring cup.
Okay.
2 cups. And if you pour a little over, that's okay. We can back it out.
I can pour 2.
Can you see it?
I can pour
Okay. Okay, go.
2 cups. Okay.
Perfect. Yep. Can you put that in here?
Yes.
Thank you. You're doing a great job. Okay. Now, little drops. That's all right. Just a few drops. Can you please, I know these are tiny, so I'll help you look. Can you please put the thermometer in there, and we're going to measure the temperature of that water. Is the needle moving a little bit?
It's like 70.
70. Perfect. Okay.
No, actually,
Let's see. I know they're small, so you just have to figure it out. Oh, that's right.
it's exactly at
Exactly 70. Okay. So can you write 70 above number 1?
Right here.
Above right there.
Okay.
Okay, perfect. Okay, let's put it in container number 2. Right in the middle. Is it climbing up a little bit?
Yeah. It's at about 90.
Let's see. Let's give it a few more seconds.
It's like at 100.
Ooh, it's almost to 100. So would you say like
I would say
90 what? You tell me. I know
would
they're
say
it's
92.
92. Okay. 92. Okay. Now, so we've measured the 2 cups of water. We're going to look at our steps to investigate. Okay. So we've measured 2 cups of water, and we've measured the temperature.
Mm-hmm.
So now you're going to put 5
drops.
5 drops. Would you like to test using this first, or you want to just try it?
I'm just gonna try it.
Okay.
In what one?
You've done it. Have you done it before?
What?
5 drops
In what?
into red and into number 1. Careful. You squeeze it.
Oh, you have to squeeze it. Okay.
1,
2, 3, 4, 5.
Okay. Perfect. Now do this one real quick, and then we're going to start observing.
Okay. We have to go fast.
Just
2, 3, 4.
okay.
Okay.
Now,
Oh, that one's like already like.
wow.
100.
Okay.
But
Okay.
this
Ready?
one's taking a little bit longer.
Let me start this timer. That was supposed to be going right here. Okay. At 20 seconds, I want you to tell me what you're looking at.
What do you mean?
Well, after 20 seconds, I want you to write down a couple words of what you've observed.
The red's right. Almost done.
Oh my goodness, it is going kind of quickly, isn't it?
That one's going quickly. That one's going slow.
That one's going quickly, and that one's going slowly.
Yeah. Oh, it's already passed.
Okay, so write down here. Write down.
After 20.
Write down like a couple words. So this is describe this.
Fast.
Fast. Okay.
How do I describe it?
Okay. What else?
Fast. Already read.
Okay. Already read. Okay. And then the next one. So we're gonna get moving here. It's kind of like a blob.
Yeah, I would say blob.
Okay.
I don't know. That's what that is.
Okay.
Blob.
All right. So we're gonna give you a few more.
It's already at 4.
That's okay. All right. So this one's
It's still red.
okay. Whatever you think, they're your observations. Okay. What's this one?
Slowly.
Okay.
Pink.
Okay. Oop, and now.
Slowly becoming.
Okay, right in that one there. So after 60.
Still red.
Okay, go ahead.
It's still red.
Okay.
And halfway,
Okay.
I'd say.
Okay. Wow, that's interesting. So this was 70 degrees, and this was 92
92.
degrees. So what do you think happened?
I think since the hot water kind of made it like slower, but like the cold water just like it was like boom boom.
Well, you want to know something interesting?
What?
Well, okay, let me ask you this. So what we're going to do is we're sort of forming our conclusion about what we think happened.
Mm-hmm.
Okay? So you think that this result showed the colder water.
Was like.
Right, because we have this big blob here in the warm
Yeah.
water, and I can feel the water is warmer in the bottom of the bowl, and this is definitely colder.
Yeah.
Well, that is interesting, because you know what?
What?
We had an experiment that didn't turn out the way it should have.
What?
Yes, because actually, the food coloring, according to the laws of the way molecules and heat work,
Mm-hmm.
is supposed to diffuse faster
In hot water.
in hot water.
Wow. Okay, that's not true.
But isn't that interesting?
Yeah. And then like look at us now.
So you know what? Can we do one thing?
What?
Can we do it again?
Yeah.
Okay. Can you stop that a second? We're going to do it again.